Before I start, I want to acknowledge that I'll be using the word disability throughout this presentation, and I'm referring to the mismatch between the objects and environments in a person's life and their body. I'll also be using terms for people's bodies and disabilities that they identify with and acknowledge that other people may use different language. Thank you. My name is Corey McClelland, and I have a disability. I have dyslexia, and some refer to this as an invisible disability. It means that it's not readily apparent that I have a disability when you meet me. Like a lot of people, I've entertained the thought of becoming an astronaut. NASA isn't explicit about dyslexia being a disqualifier, but the required testing would most likely weed me out. Unfortunately, that's not the only reason. I don't come from a military background. I don't have the right type of STEM degree. My vision may not be good enough to pass, and I'm about 2 inches too tall. Eric Ingram, on the other hand, has the credentials, and he's applied to be an astronaut. He has a bachelor's in physics, a master's in engineering, but he's not expecting a call from NASA anytime soon because he also has a disability. Despite being a highly qualified individual, being in a wheelchair is a non-starter for NASA. This begs the question, who has access to space? In 1959, the United States selected 7 test pilots to kick off their space program. They were referred to as the Mercury 7, but also known as the Right Stuff. In 1967, the definition widened to include Robert H. Lawrence, the first African American selected for a space program. Widened further in 1972 to include non-military background with American geologist Harrison Schmitt. 1978, widened to include women. And then in 2021, Blue Origin widened it even further, flying William Shatner, a 90-year-old actor with advanced arthritis. So why not people with disabilities? Well, the European Space Agency is asking this exact question. They've just selected John McFall for their astronaut program. He's a surgeon, an athlete, and has an above-knee amputation. So it's not that we can't, it's that we haven't. I've identified 3 reasons why disability inclusion is important for humanity's future in space. First, designing for disability is good for business. SpaceX, Blue Origin, and Axiom are already sending civilians to low Earth orbit, with bigger plans of private space stations on the horizon. 16% of the global population experiences significant disability. When disability is not being designed for, these companies are ignoring 16% of the potential market. Second, designing for disability makes space safer. I've had conversations with Sarah Hendren, author of What Can a Body Do? And we talked about this idea of disability being a fundamentally human experience. This means that almost everyone will experience disability at some point in their life. Space is no exception. Another way of thinking of this is disability as permanent, temporary, and situational. A permanent disability would be something like blindness. A temporary equivalent would be like getting something in your eye obstructing your vision, and the situational equivalent being the lights going out. And third, designing for disability drives innovation. Rama Girabo, director of the Helen Hamlin Center for Design, puts it best when talking about disability innovation: never underestimate the power of dissatisfaction. We know this here on Earth with the invention of SMS, closed captioning, and the remote control. And there's an organization doing this foundational research to widen this definition even further. This is Astro Access from their first flight. They charter zero-G flights and select individuals with a variety of sensory, mobility, and cognitive disabilities to fly. They do this to better understand what life will be like in space. I partnered with Astro Access to design several prototypes and experiments through co-creation workshops, prototyping, and disability-led design in collaboration with Miki Benthaus, Jose Luis de Augusto Gil, Dr. Sherry Wells-Jensen, Victoria Modesta, and Sana Sharma. And I'm excited to share 3 of these projects with you today. This is wearable inkring. It was born out of conversations with Miki, a German engineering student who has a spinal cord injury resulting in paralysis below the waist. We were tasked with developing experiments for her to execute on the zero-G flight. We explored what life would look like for her in space and observed that in order to complete tasks like working on a payload, recording an interview, or even playing the flute, Your feet are required to stabilize or anchor yourself to prevent you from floating around the craft. We collaborated remotely through messages, Zoom calls, and sending videos of prototypes. And since Miki has paralysis below the waist, we explored a variety of ways that she could attach herself to the surfaces in space. Here are some ideas involving magnets, Velcro, clips, leg straps, and a variety of harnesses. The design we arrived at was a simple belt with extendable attachments. Taking into account the physics of zero-G, we felt that it was important to have the attachment point near her center of mass. And on each hip is a telescopic arm with Velcro attachments at the ends, allowing her to attach to nearby surfaces. Several days before the flight, we were able to work together in person and alongside retired astronaut Katie Coleman to refine our in-flight plan. I stayed on ground and Miki and Jose Luis, a pilot, test flight engineer with paraplegia, went up with the rest of the crew. First, I want to point out just how fun zero-G is. Miki and Jose Luis took turns testing the wearable anchoring prototype. Part of this experiment was for them to perform a fine motor skill task with both hands to measure the efficacy of the design. But we also wanted to understand how easily they could perform the task without devices for additional context. And we caught this amazing moment where you can see just how crucial anchoring in zero-G is. Here you can see Jose Luis performing the task with the devices. And this is Jose Luis trying to perform the task without them. The experiment was a huge success. We learned so much about the value of anchoring and started to identify criteria for restraints and mobility aids for crew with paralysis, lower limb difference, and lower limb amputations. The next project I want to share with you is TouchPath. I worked with Dr. Sherry Wells Jensen, the NASA Library of Congress Chair in Astrobiology, Exploration, and Scientific Innovation. Sherry is blind and has been on 2 zero-G flights with Astro Access. From those flights, she has a good understanding of what she would need to live and work in space. The biggest opportunity from her experience is communicating directionality and orientation. Astronauts currently rely heavily on their sight to navigate and orient themselves and to others and their surroundings. Without gravity, our inner ears are incapable of determining up from down. Sherry connected me with the New York Public Library to host a workshop with members of the blind community. And Sherry started the workshop by describing her experience on these flights. And I followed up by describing Newton's third law. For every action in nature, there is an equal and opposite reaction. Meaning that if you touch a tactile braille sign on a wall in space, you're actually pushing yourself away from that wall as you feel it. I created a variety of stimuli ahead of time to talk about directional textures, emergency information aboard the ISS, and other tactile variables. I passed these around and we discussed the qualitative attributes of directional patterns, the legibility of tactile icons, and what each of their preferences would be in space. Another section of the workshop was spent generating ideas for tactile communication. We used a slate and stylus, which is used to manually punch braille, and a sensational blackboard to draw and emboss shapes and patterns on paper. Throughout our conversations, it became apparent that the greatest opportunity for this work is on handrails. Handrails are already being used to stabilize and traverse in zero-G, so why not include additional information which could be used by all crew? By placing a subtle pattern on the face of the handrails, you can communicate directional information like an emergency exit route or orienting crew to the front of the craft. And by placing more detailed information on the back, crew could locate a fire extinguisher, medical equipment on an opposite wall, or know which module they're about to enter. The last project I'd like to share with you is called MESA. This stands for Modular Ergonomic Space Accessories. I wanted to explore the next steps based on the findings from wearable anchoring. This prototype worked, but it was essentially designed for Miki and Jose Luis to adapt to the International Space Station. Which made me think, what if the environment adapted to the individual? I partnered with Miki again, as well as Victoria, a performing artist, model, and amputee, and Sana, a co-founder and the the co-founder and chief design officer of Aurelia Institute, an organization exploring humanity's futures in space. I explored these objects through the lens of furniture typologies, imagining what chairs, tables, and storage could be without the constraint of gravity. The idea of flexible arms stood out as a simple, adaptable, and ergonomic solution. I made these early prototypes from foam and gooseneck stands, and they were unexpectedly comfortable and strong enough to stabilize in a microgravity environment. As I continued prototyping, I explored ergonomic pads for comfort, different material combinations, and the attachments which would enable the arms to interface with existing environments, tools, equipment, and other crew. I designed 3 lengths of the arms, which were made of cast foam surrounding a flexible aluminum core. These are lightweight base components of a suite of objects that work together through friction fit assemblies, comfort pads for long duration use, and a variety of extensions and attachments. The system interfaces with specialized tracks that are already being used on the International Space Station, and the arms can hold a variety of objects via clips, straps, and magnetic pads. They also enable social interactions. And beyond the starting point of anchoring, this modular furniture allows you to be you in space. Due to the simple design, the suite is highly customizable and infinitely expandable through 3D printing in zero-G. And I'm excited to announce that later this summer, MESA and TouchPath are slated to be tested in zero-G flights with Astro Access. Thank you so much.
Thanks, Corey. That was fabulous.
Thank you so much.
Tell us more about the relationship and nuances between universal design, inclusive design, and disability-led design.
I'm glad you asked that question. I really started this project, all of these projects through, and my thesis, as you remember, through this lens of how do we make space more inclusive? So I examined universal design as an opportunity, inclusive design primarily, and I think a lot of the examples that get brought up about a universal design are actually more than that. They're actually the result of an inclusive design practice, and so universal design as the goal at the start is not easy because you're trying to take into account a lot of variables and trying to make the most inclusive design possible that works for everybody. And so actually through inclusive design practices where you're designing for a very specific disability or people group, then there are universal design implications that come along with that. And so while working with Astro Access, it became very apparent that what we were doing was not really inclusive design either, but disability-led design. And so through inclusive design, it's saying, we're going to have you at the table, you're going to be part of the conversation, then you're going to go away and we're going to do the thing. Whereas disability-led design is really at the core of what I was doing, especially with Miki and Sherry. And it was a partnership. It was something that we were having ideas working together, and I was taking their lead because I'm not the subject matter expert on their disability, but I am a subject matter expert on design. And especially in the context of space, there's this third component, the subject matter expert of designing for zero-G. And it's really bridging the gap between these 3 disciplines and 3 experiences that really this work started to form into. I think it was that. Thank you.
Yeah, that's great.
Yeah, it is. It's wonderful that your work actually enables others to live to their fullest potential. And I would say your work's really, in the sense, co-creation, fundamentally co-creation, collaboration. And so you've worked with organizations. How did you land these connections?
Yeah, I actually, last year, I competed in the Caltech Space Challenge, and I ended up connecting with one of the founders of Astro Access. It's a fairly new organization, and they had just finished their first flight right before I met him. It was George Whitesides, and he very quickly introduced me to the rest of the group and said, "Hey, Corey's going to be working with us now," which was very fortuitous and fortunate for my thesis work, and it was just really exciting to get a chance to work with all of them. And I'm actually now volunteer still, but director of flight operations with Sherry. So
Wow.
I am part of the Astro Access family now, and it's amazing.
That's great. It's so great to see that they're kind of so open to collaborating with people, right? That it's not this like, we're going to do this behind closed doors.
Yeah, and I think that's actually like at the heart of everything that we do at Astro Access. It's about collaboration, and we're doing amazing things that haven't been done before. And so you need all the help that you can get, and you want to make sure that it's as diverse as possible to make it the best possible product at the end.
Do you think we'll fit in their luggage?
Oh,
I
hope
want to
so.
go for a ride.
Yeah, me too. The last question for you, I would say, is what do you think is the most important thing for the general public to know about designing for disability? Maybe you already answered part of that question with question one, but
Listen, ask questions, partner. Don't make assumptions. Have a conversation and take their lead. Like it's not about designing for them. It's designing with them. It's alongside.
it's not rocket science.
That was good.
Thank you.
Thank you so much.
Congratulations.